4, graphs of the secant and cosecant functions. So you're going to graph secant and cosecant functions given an equation using sine and cosine as a guide. So first thing we need to know, vertical asymptote, vertical line that the graph approaches but does not intersect, while function values increase or decrease without bound as x values get closer and closer to that line. So one of the things we have to do that's a little bit different from sine and cosine is finding the secant, finding those asymptotes. So exploring this, we're going to look at the graph of y equals secant of x. Remember, secant of x is 1 over cosine. So we have to look for our cosine values and then flip them over. Cosine at negative pi is negative 1. At negative 3 pi over 4, it is, so we're looking cosine. Cosine will be radical 2 over 2, actually negative radical 2 over 2, which is negative radical 2. At pi over 2, cosine is 0, so secant would be undefined. Pi over 4, cosine, again at negative pi over 4, cosine is radical 2 over 2, so this will give you radical 2. At 0, it is 1. Pi over 4, it's radical 2. Cosine 0, so it's undefined. This is supposed to be 3 pi over 4 down here. So let's fix that. 3 pi over 4 is going to be negative radical 2 and then negative 1. So what we're looking for in here is where those vertical asymptotes are. And you're going to have a vertical asymptote here, and you're going to have a vertical asymptote here. But notice it is whenever cosine, when cosine of x equals 0. So that's one of the things we're going to use when we graph these. So let's do the same thing with cosecant. Remember, cosecant is 1 over sine. So we have to take our values of sine and then flip them over. At pi or negative pi, doesn't matter, sine is undefined. Well, sine is 0, so cosecant is undefined. At negative 3 pi over 4, sine is negative radical 2 over 2, or negative radical 2. At negative pi over 2, sine is negative 1. At negative pi over 4, sine is still negative radical 2. And at 0, it's undefined. Pi over 4, sine is radical 2 over 2, so we get just radical 2. At pi over 2, sine is 1. 3 pi over 4 is radical 2 over 2, so just radical 2, and then undefined. So on this one, our vertical asymptotes, again, is going to happen where sine equals 0. So vertical asymptote is when sine of x equals 0, because that makes cosecant undefined. So now we're ready to jump into our 3 graphs and look at the different things that are going on. All of this did was to identify when and why. The vertical asymptotes happen whenever cosecant is undefined or when sine is 0. Okay. The steps, I'm not sure how much it's going to help you, but I do get to throw this out there. When you're graphing cosecant, use sine as a guide. If you're graphing secant, use cosine as a guide. So we're going to go through those steps just as if we're going to graph them. Sketch your vertical asymptotes. They will have equations of the form y equals k, where k is, don't worry about that. Sketch your vertical asymptotes. This is where they equal 0. The sine and cosine values equal 0. So I'm going to throw that out there. When sine of x or cosine of x equals 0. Then sketch the graph of the desired function by drawing the typical U-shaped branches between the adjacent asymptotes. So I'll still talk about all of those. So the very first one, so we have y equals -2 secant 1/2 x. We are going to pretend that we are graphing y equals -2 cosine of 1/2 x. And before you stop and go, wait, what? Secant and cosine are reciprocal, so they're going to have common values. So what we're going to do is, remember, you're graphing secant, you're using cosine as your guide. So this is how we use cosine as a guide. We go through the typical steps. A equals -2, B equals 1/2, which gives us a period of 2 pi over 1/2, or 4 pi. Our C value equals 0, and our D value equals 0. So we don't have to worry about those. So I'm going to graph this thing from 0 to 4 pi. So as we've done before, I'm going to graph that baby as 4 pi. Halfway there is going to be 2 pi. And I'm going to throw in my quarter points. Now, we have an A value of -2, and cosine has that pattern of 1, 0, -1, 0, 1. So we're going to multiply by -2, 1, 0, -1, 0, 1. So we're really going to graph 2, 0, 2, 0, -2, -2. So here's 1, here's 2, let me play my 2. Here's 1, here's 2, let me play my 2. And so my first point, I'm going to go to a different color to graph the points, because I want to make sure you guys see the difference. -2, the next one is 0, then at +2, and at 0, and then at -2. And that is where it stops looking like cosine. So plot points and stop. And this is where secant begins. So step 1 really is pretend you're graphing the cosine curve. All you do is plot the points and stop. And that's where secant begins. First thing first, draw in your vertical asymptotes. So I'm going to grab my vertical asymptote. Everywhere the cosine values are 0. So I have a vertical asymptote here. I want that to be a dotted line. Go back. Here. And I have another one here. Let me straighten those things out. Okay, moved over. This guy needs to be moved over. But we have nice little vertical asymptotes going. First one. Second thing I would tell you to do is draw a U on those U at the max. And an upside down U at the min. So this is a min, so I'm going to draw an upside down U. This is a max, so I'm going to draw a U. And this is a min, so upside down U. One thing left, step 3. Extend them towards the asymptotes, the vertical asymptotes, your dotted lines. So I don't have one on this side, so I'm not going to extend that side, but I'll extend this guy over. This one I have it on both sides, so I'm going to extend both sides up. Now this should look much more like a U. And again, I don't have one on this side, so I'm going to extend this one over closer to my asymptote. And there's your graph, you're done. Here's the main thing to know. your asymptotes, unless your graph has been moved up or down, your graph should never cross the x-axis unless it's moved up and down, and then it will never cross that line where it was moved up and down. Okay, let's try another example. So this one is cosecant, so we are going to pretend that we are graphing sine. That this is y equals sine of x plus pi over 3. So my a value equals 1, my b value equals 1, so my period is 2 pi, or 360 degrees. C equals 0, and D equals negative pi over 3, or negative 60 degrees. That is your phase shift. That's what they're telling you they're going to move. So double check my beginning endpoints. I do a 0 is less than or equal to the x plus pi over 3, but I know that's 60. Plus 60 is less than or equal to 2 pi, or 360. Subtract 60, subtract 60, subtract 60, and we get negative 60 is less than or equal to x, which is less than or equal to 300. Or negative pi over 3 is less than or equal to x, which is less than or equal to 5 pi over 3. There's our links that we're graphing. Okay, and I verified my phase shift that it was negative pi over 3 because I would have got the same thing here. This happens sine, cosine, secant, cosecant. So sine's pattern is 0, 1, 0, negative 1, 0. I don't have an A value, don't have a C value, so those are the points I'll be graphing. So I come to here, and since I'm not starting at 0, I can't come over here and claim this to be 5 pi over 3. I have to identify all of my pi over 3's. So my first one, negative pi over 3, 0 pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. 5 pi over 3, there's my start point. Negative pi over 3, my actually end point, start point. But notice that we have a lot more than 5 dashes. We should only have 3 in between. So we got to find our midpoint. Our midpoint between these, you've got to add them, divide by 2. So 5 minus 1 is 4, divided by 2 will get me 2 pi over 3. Yep. So there's my midpoint, 2 pi over 3. So what I'm going to do, I have my 0 value here, and this one, there's my, so this is 60, 60, and 60, 60, 60, and 60. We can see that that's in there. So I'm going to erase my points in between the ones I identified. So I want you guys to see this. There's my start, there's my end, there's my midpoint. And again, to get the midpoint, you add the 5 minus 1, you get 4, and 4 divided 5 minus 1 is 4, divided by 2 is 2, so you get 2 pi over 3. Now, you don't have to tell me these quarter points, you're just going to throw them in. You just got to keep in mind that this, you got to kind of ignore this guy. This one here is going to be right about here. By the way, this one's pi over 6, and this one's 7 pi over 6. Okay, and we're ready to graph our points. But again, I want you guys to make sure you see this, so I'm going to throw this into a different color. So my first point is at 0. My next point is at 1. I guess I could have thrown my 1s in there. It's at 1, back to 0, down to negative 1, back to 0, and that's where we stopped. And we're ready now to graph cosecant. So reminder 1, vertical asymptotes is first. Everywhere that you put a dot on the x-axis. Okay, let's straighten those up. Back over, straighten this guy up. Kind of over, straighten this guy up. Looks like it's still messed up. Okay, 2. Your U or upside down U. So this one here is a max, so a U. This one here is a min, so a U. And then 3, extend them. So this one's going to go out that way towards the vertical asymptote. This is going to go this way towards the vertical asymptote. This one will come, I don't like that one. This one's going to come down towards the vertical asymptote on both sides. And there you have it. And you're done. Now you can dot in if you want. You can dot in your curve so you can see the curve. But I need to throw this out there. You might not want to get in that habit because the curve is not part of the graph. But you can at least see that you don't cross the curve. If you dot it in, you should never cross that curve. It touches it and that's it. Okay, one more example. Now, if you want, pause this and try and do it yourself, or you just keep going. Okay, if you pause it, then you're ready to start looking and see if you did it right or not. Secant is cosine, so we are going to pretend that this is y equals 2 plus 1/4 cosine of 1/2 x minus pi. This one has everything on it. Okay, A equals 1/4. B equals 1/2. So the period is 2 pi over 1 divided by 1/2, which gives us 4 pi. Our C value equals 2, and our D value equals, you got to be really careful because this 1/2 is inside. So if I was to take this and do 2 over 2, so I can take a 1/2 out, anyway, so I can take that common denominator out, you can see I'm going to be left with 2 pi. Okay, so let's do the quick little inequality to verify that we got the correct value here, because if that is the case, then we're going to start at 2 pi. So I have 0 is less than or equal to 1/2 x minus pi is 180, which is less than or equal to 360. Add 180, add 180, add 180, and we get 180 degrees is less than or equal to 1/2 x, which is less than or equal to 540. And then multiply each of them by 2. I get rid of this 2 here. So the 2's cancel out and we get 360, which is 2 pi, is less than or equal to x, which is less than or equal to 540 times 2, 540 times 2 is 1,080. Unless I did the math wrong. 1,800? I think it's 1,800. We get a 0, and 2 times 4. Well, maybe it's 1,080. Okay, I'll do the math this side. 540 times 2, 0, 8, 10. Oh, okay. Less than or equal to x, which is less than or equal to 1,080. And if our thing is 4 pi, that should be 6 pi. So let me just double check. Gives us 6. So we get 6 pi here. So there's our start point, there's our end point. So let's go ahead and set those up. So I'm going to just do these by pi. There's 1 pi, 2 pi, which is my beginning point, 3 pi, 4 pi, 5 pi, 6 pi. 6 pi is my end point. This would be my midpoint, which would be 4 pi, and my quarter points. Notice my quarter points are in there. Now, we've got a lot going on because we have an A and a C value. And this is cosine. Cosine is 1, 0, negative 1, 0, 1. And we have to multiply that by 1/4. So it's 1/4, 0, negative 1/4, 0, and 1/4. But then we have to go through and add the C value. Plus 2, plus 2, plus 2, plus 2, plus 2. So the points we're going to graph is going to be 2 1/4, 2, 1 3/4. Please think quarters when you're doing this math. If you had $2 and you gave a quarter away, you'd have 1 3/4 quarters kind of thing. The next one is 2, and then 2 1/4 again. And we're ready to plot our points. Well, almost. Okay, so these are in fours. I'm going to throw this as 1, and this is 2. Notice that none of my values I'm going to graph are negative, so I'm not going to worry about negative values. I am going to do this one little bitty thing. That might throw some of you off. Actually, I'm going to undo that one for a second. I'm going to put it as this dotted line. I don't mean to throw it off, but this is my new 0 line, and so this is might make it a little bit easier for me to follow through with things. So if this is 2, this is 1, this would be 1 1/2, and this would be 3/4. And then so barely up there would be the other one. And we're graphing 2 1/4, so, we're starting at 2 pi, graphing 2 1/4, and then at 2, and then 1 3/4, back to 2, and then up to 2 1/4. Notice this is a very, very shallow graph. Now, we're not typing in the things, but the purpose I put this line in for is because these used to be your zeros. And when I moved it up 2, just slid this graph up 2, that's where my zeros went. So we are now able to say, oh, I'm done graphing this, the cosine version of this. Now it's time to do secant. Remember secant 1, vertical asymptotes, 2, your u's, and 3 is extend. Okay, So vertical asymptotes, here we go. Everywhere I see the 0. There's that one. Yes, I realize it's crooked. And then there's that one. Let's fix this one. And then at our max and mins, we are going to put in the u's. At the max, it is u. At the min, it's an upside down u. And again at the max. And then extend them towards the vertical asymptote. So that one's going to go that way. This one's going to go this way. And this one's going to go this way. You can extend this one, but you don't have the vertical asymptote on this side, so I would say just not do it. But there you guys have it. So there is your graph. And and you are done. Now, I know before I said you shouldn't be crossing the x-axis, but I did say unless you have a c value. What happened is that my entire graph got pushed up to here. Otherwise, it would be way down here. Okay, and that is it. Unfortunately, this one took a good 30 minutes as well. There is the homework. I am not changing or adjusting the homework, so there you guys have it.